Okay, so welcome to the first recording of a tutorial, if you will, to review and go over how we solve for x when we have these very complex equations or expressions rather on both sides of the equal sign. So the question that I'm going to be using today as a sample is question number 3 from the 8th grade algebra unit 1 assessment, so where we're dealing with linear equations. And the question states, what value of x makes the equation 3 times x minus 6 minus 8x equals negative 2 plus 5 times 2x to the plus 1 true? And basically, that's a question that's asking us to solve for a value that can go into each of these x's that will make this statement true. So we know that the basic steps that we have to take in order to solve for x is to create a story of x. And with simple linear equations where we might have one or two things that we have to do, or really essentially when we have one variable, we can do that quite easily. That's something that you have all been practicing. But before we can even create the story of x, what we have to do is we have to deal with all of these different x's that are showing up in the equation. So what is the first thing we're going to do? Our step 1 of solving complex linear equations states that we are to distribute. So we want to be able to apply the distributive property because this entire expression of x minus 6 is being multiplied by 3 on this side. And on this side, the 2x plus 1 expression that's inside the parentheses here is being multiplied by 5. So again, let's go back to our steps. And you've been instructed to write the steps on one column and then to actually solve it in the next. So let's go ahead and rewrite this on this side and distribute. So we're going to say 3 times x, which is 3x, and then 3 times negative 6 is negative 18. And of course, we get rid of the parentheses because we've distributed. And now we're going to bring everything down, on at least on this side of the equal sign, because the first step we're doing is we're just distributing, right? So it's 3x minus 18 minus 8x. Next, we want to deal with the distributive property here, right? But we also want to be able to bring down the part of this sort of side of the equation or expression. We want to be able to bring down what we're not doing anything with at the moment. So we're not doing anything with negative 2, so we're just going to bring it down exactly like so, right? And then let's go ahead and apply the distributive property. So always remember, guys, when we are applying the distributive property, it's a number, and sometimes that number can look like a negative, but I don't want to like distract you a little bit. So let's just focus on what we have here. It's basically the number right outside that comes before the parentheses, never after. Before the parentheses, we're going to multiply 5 into each of the terms in this expression inside the parentheses. So 5 times 2x is, and remember, we can't forget that addition. And we know it's positive, so that's going to stay in addition. So it's 10x, and then 5 times 1 is 5. Okay, so using the distributive property in that first initial step, we've gotten rid of all of the parentheses. Now we are ready to see if we can combine any like terms. This is something that hopefully we mastered in 7th grade, but sometimes, we don't, and that's okay. So we're going to do a review because the thing is, we've got all these different x terms that we have to deal with, right? And so the first thing we want to do is remember we have one expression here, right? So this is one expression 1, and this is another full expression 2. Okay, and remember, guys, all of these sort of steps that we're taking immediately now is to simplify this entire equation that is made up of these two expressions so that we can create that story of x. Okay, so here we go. So the second step that we take after we distribute everything is that we combine like terms, right? And when I say combine like terms, we're talking about combining like terms on this side of the expression first, and then combining the like terms on this side of the expression before we can apply some of those basic steps of solving for algebra. So what I've done to kind of illustrate this a little bit better, hopefully, is I went ahead and made up some tiles for you so that you can clearly see what we mean by like terms, okay? So right now we have 3x minus 18. So I have 3x minus 18, and I'm using two different colors to remind us that 3x, the variable term 3x, and the constant of negative 18 are two different terms. What we say in algebra is unlike terms. So we have on one side 3x minus 18 minus 8x. And I notice that I use the same color yellow because even though the coefficient, which is the number in front of the variable, 3 and negative 8, are different, they share the variable term of x. So we call them like terms, okay? So I've sort of created this expression with the tiles, and I'm going to put a little equal sign. And I'm not putting any like subtraction or addition because 3x negative 18 is an indication that we're basically saying 3x plus negative 18, okay? So 3x minus 18 is the same thing as saying 3x plus negative 18, but I don't want to distract us too much. So the next one that we have then is a negative 2. And then we have, what do we say? 10x plus 10x. And again, I'm not putting the addition there because it's implied. We're not multiplying this, but the implication is that we're adding. And I'm just going to show you what it means. So here it's 3x minus 18, 18 minus 8x. And here the implication, because there's no negative in front of the 10x, is that we are adding these terms. We can't add them quite yet. And of course, last but not least, we have our tile of adding a 5. So basically what I've done is I have represented for you guys in different colors like terms and unlike terms. And as you can see on this side, we have two like terms between 3x and negative 8x. And on this side, we have the constants negative 2 and 5, which are our like terms, right? So again, going back to step 2, what we're going to do now is we're going to combine like terms. And a good way for us to do that, and something that I've been practicing with the students in 7th grade, which has been really helpful, is that we can reorder them around so that the like terms are kind of next to each other. And this sort of in some ways group, and then we're then regrouping them too, right? And that helps us to kind of keep everything in track. So here I would write like 10x, right? And then 5 minus 2 to just keep everything in track. And I can reorder these now so that what I have written here is going to be represented by your tiles, and hopefully you'll see. So I'll just say 3x minus 8x, right? So those are going to be grouped together. And I'm not going to put the parentheses because it's already written here. And then we're going to say minus 18. And then we have 10x, right? 10x plus 5 minus 2. 5 minus 2. You see that, hopefully. Okay. All right. So we can now combine like terms. Again, we're not solving for anything quite yet. We're just simplifying this entire equation and expression on both sides so that we can actually solve for x. So 3x minus 8x gives us what? It gives us negative 5x, right? Okay, because if we start off from 3 and we move negative spaces 8 to the left on a number line, it'll have us end up at negative 5x, right? And then it's negative 5x what? Minus 18. Hopefully you guys see that. So, because remember, we haven't done anything with negative 18. Negative 8, or minus 18 rather, has not disappeared anywhere. So we're going to bring that straight down. And I know some of you have been writing like the equal sign like this. So if that helps, you're more than welcome to do that. Just so that we remember that whatever, when we start solving for x, that whatever we do to one side, we'll do to the other. And of course, here at this point, we're just being reminded that we've taken care of the expression here and we've simplified it, but we've also got to do the same thing for this side. So again, going to the like terms, we combine them, and then what do we have, guys? We have 10x, we bring that down because remember we're not doing anything with that right now. And we have 3, right? Okay, great. So now we have a much more simplified expression where we have negative 5x minus 18 equals 10x plus 3. Whew, that is much easier to deal with than whatever we had going on here or even going on here, right? So we have simplified a lot. Now what I'm going to do is I'm going to switch over the tiles to kind of reflect the combining of like terms that we did. I'm just going to flip it around. I'm going to write negative 5x on this side, right? And we're going to keep the negative 18 because we have that. I'll move that because we got rid of that by combining the like terms, right? Negative 5x minus 18. And then I'm going to keep the 10x. And instead, I'm going to take this away, flip this over, and write 3 on it. So now we have a physical representation, right, we have a physical representation of this simplified expression that we have. So negative 5x minus 18 equals 10x plus 3. All right, great. So what is our third step? Well, we want to be able to solve for x. Remember, let's go back to that original intention or goal of this problem. We want to solve for x. And remember, the thing about solving for x means that we need x on one side of the equal sign because eventually we want to be able to get to a place where we're saying x equals a numerical value, right? That's what we're trying to do. But the problem here is that we have the x term on both sides. So then that takes us to our third step. Our third step is to move our variable. And of course, if we didn't have 10x, we wouldn't even have to do this step, right? But that 10x is getting in our way. So we have to move our variable to one side. Now, mathematically speaking, we could move this to this and this to this, but we have really kind of gotten used to solving it so that x is on our left and then our numerical value or whatever solution the x is on our right. So just to be consistent with that, we're going to do that. Well, here's the thing. We have like terms on either side of the equal sign. And when we had like at this step here, when we had the like terms on the same side of the equal sign, we could just add them together and just, straight up add them or subtract them and then combine. But it's a little different when we have these like terms on either side of the equal sign because right now, what this is mathematically telling us is that whatever this is the same as whatever this is, right? So basically, we've talked about this before with algebra that, algebra is a lot like keeping a balance on the scale. And so the idea is that whatever we do to this side, right, we've got to do to this side. And the way that we move things around in math is we make things equal to 0 or 1. And in this case, because we want to get rid of this variable, we want to quote unquote move it, we want basically this 10x to go away, right? But in math, we can't just take it away. I mean, we can, but the way that we take it away is we make this a 0. And how do we, because remember, 0 is nothing, right? And we want to get rid of it. So how then do we get rid of this 10x? Well, we know that if we have a 10x, in order to make that equal 0 or to take it away, we have to just subtract 10x, right? But again, the equal sign demands that because right now, before we take away that 10x, these are completely imbalanced with each other. We gotta do it to both sides. But so because I took away 10x from here, I'm gonna take it away from here physically, I need to take the 10x from this side. Okay, so I'm taking 10x. All right, so hopefully you guys are staying with me. All right, so we're going to take the 10x from both sides, and this is what's going to continue to keep everything in balance. Now, before we deal with all of this, I want to make sure that we're not leaving the constant 3 behind, because remember, we didn't do anything this constant, so the constant comes down just exactly like this, okay? And of course, 10x minus 10x equals 0, so 0 is nothing, so we're not going to put anything there. Poor 0, but that's all right. All right, so now let's go back to this side. So if we subtract 10x from 5x, that's like on a number line, okay? We have negative 5, and subtracting 10 means we go to the left 10 times. And where will that land us on the number line? It should land us eventually at negative 15. So negative 5x minus 10x is negative, and I'm going to write it on the same line as this 3, negative 15x. And remember, again, we haven't done anything to this subtraction of 18. So there we go. We're going to bring it down, subtraction of 18. So hopefully this is all starting to work out. And I'm going to change this negative 5 into a negative 15x. That was kind of easy to do with the tiles, right? So now I've got negative 15x minus 18 equals 3. So the question I want to ask before I solve for x right now is, have I simplified this original expression enough so that I only have one x to deal with and only, you know, one term on this side and another term on this side? Yes, this is about as simple as you can get for an equation. I mean, of course, the simplest would be this, but we're dealing with negative 15 times whatever that number is, minus 18 equals 3, okay? So now that we've simplified this, and again, just to remind you guys, these steps 1, 2, and 3 is really to take this very complex equation and to simplify it by combining like terms and moving our variable from one side of the equal sign to the next in order to come up with this very simplified equation. Okay, so now we're going to do that thing that we've done over and over again, which is to create the story of x. So I'm going to just write create the story of x because you guys have been really good at doing this. Okay, so again, in algebra, we use inverse operations, and we use the reverse order of operations in order to solve for x. And that's a lot of math language, okay? So I find that creating the story of x, or whatever our variable is, in this case it is x, so we're going to stick with creating the story of x. We're first going to ask ourselves, what is happening to our x right now? So it is being multiplied by a negative 15. Right, so multiply by negative 15. Hopefully you guys can see this, a little tiny, okay? And then what's happening to it? Then it's being subtracted by 18. And basically what I'm doing when I'm building the story of x is I'm talking about the order of operations. Remember, just the order of operation, I'm just going to write this down. It's grouping, right? Exponents, multiplication, division, addition and subtraction. Of course, multiplication, division is whatever comes first, right? If division comes first, you would do division. But anyway, that's getting into other stuff that hopefully you guys have mastered. So basically what I've done is I'm written in the order of operations, right? First, it's being multiplied by negative 15, right? And I'm going to actually rewrite this so that I have a little bit more room to work with because I want you guys to be able to see this. So bear with me. I'm going to rewrite this, which is another reason why it's very, very good and helpful to write or work with math, or work with pencil when we do math, sorry. Okay, so let's create that story one more time. So creating the story of x. We are saying that first it's being multiplied by negative 15, right? And then it's adding or subtraction. It's being subtracted by 18. And when we apply the inverse operations to, you know, get rid of 18, because again, we want to isolate the x, we're going to use the order of operations going this way. We're going to go backwards, okay? And we're going to use the inverse operation, which is the opposite. And this goes back to the idea that if we want to isolate the x, we got to get rid of this number, and we got to get rid of this number. And the way that we get rid of a negative 18 is to add its opposite, which is positive 18. So that's the same thing as saying, right, add 18, right, and that'll get us 0. And again, because it's being multiplied by 1, we don't want it to equal 0 because we got to solve for x. So we want this, the intention of this is to make sure that negative 15 is somehow becomes a 1 so that we're left with that variable of x. And if right now, if you're a little confused by what I said, hopefully it'll become a little bit more clear as we solve this. Okay, so multiplying, the inverse operation or the opposite operation of multiplying is to divide by the negative 15. And please do not forget that negative sign, okay? All right, so let's do this. Remember, we want to apply the story of x by doing this first now and doing this. Okay, so we build up, but we build down going this way, okay? So we're going to add 18. And again, that same rule that right now it's in balance. This is in balance, right, guys? So whatever we do to this side of the equal sign, we must do to the other. And again, we're trying to get rid of this negative 18, and we do that by adding 18, get 0. But because we added 18 here, we're going to add 18 here, right? Great. And that will give us 21. And again, this hasn't gone anywhere quite yet. So we're going to write negative 15x, right? And we're going to divide. Remember, we're going to divide by negative 15. And again, I know some of you guys have been doing this where you go divide by negative 15. But what I really want you to do is I want you to practice writing division as a fraction. So we're going to use that fraction bar, and we're going to divide it by negative 15. And again, this equal sign demands that whatever we do to this side, we must do to this side. And you'll see, because our solution for x is going to end up being a fraction. And see, when you put the division or represent the division with the fraction bar, because negative 15 divided by negative 15 is 1, and 1 times x is x, you will see easily that this is a fraction. Now, here's the thing. Now this negative applies to this entire fraction, right? Negative 21 over 15, right? Well, we're not quite done. We're almost there. We're almost there, okay? And what you can do now is you can simplify. So how would we simplify negative 21 over 15? We would simplify it by what? What's the common factor between 21 and 15? Hopefully, you guys know it's 3. So it's negative. So your solution should be negative 7 over 5. Right? Because 15 divided by 3 is 5, 21 divided by, or negative 21 in this case, divided by 3 is 7. So your solution is x equals negative 7 over 5. One great easy way to check your solution, guys, if you're feeling unsure about it, is to then take this solution, because you're saying that x is equal to negative 7 over 5. And what you could do is you could go to that original problem, and wherever you see x, you would substitute negative 7 over 5, right, into each of these x's, solve it, and see if this expression is the same as this expression. So I'm not going to do that because this is going to make it a really long video, but hopefully this has clarified for you guys the steps that I want you to go through anytime you are solving these complex fractions or complex linear equations. And again, they might not always be this complex, but if you can stick with these steps of distributing, combining like terms, moving your variable to one side, and creating the story of x, and you can watch this video as many times as you need, then you will be well on your way to really, I think, 100% in being able to solve these. Okay, I hope that was helpful, and I wish you the best in all of your solutions for your variables. Okay.